Okay, folks, let's talk about chapter 1, section 6. This is the last section of the chapter. It's on limits at infinity. Okay. Well, first I'll start off by doing the warm-up. Now, I've already gone ahead and started some of it. I went ahead and drew the asymptotes, which are all at x equals 4. I did them in highlight because it's easier to do it on this screen than with a highlight than it is to try to do a dotted line with the pen. For some reason, it doesn't work as well. All right. Now, I'm going to go ahead and draw these curves the way they should look. You can practice it on your own with your own graphing calculators. The curve should look something like this. They should look like now, mind you, these aren't the best, but you get the idea of how they work. And then I'll talk about it as we go through it. Okay. Now, 1 over x minus 4 looks like something like this, with both curves being in the first and the third quadrants. Now, when I say first and third quadrants, think back to Algebra 1 and even geometry when you were dealing with where they were located. In this case, it's in relation to the asymptotes. Now, because it's negative, it's going to be the opposite places. It's going to be in quadrants 2 and 4. Now, for the third one, because it's x squared, no matter what x value you use, you're always going to have a positive number. So therefore, your graphs are going to be both in the first and second quadrants because you have y values that are positive. And then the last one, because you have -1 on top, and whenever you square a number, it will always be positive. Negative and positive make it negative. So therefore, it's going to be down in the third and fourth quadrants because we're dealing with the y values. All right. You can do those on your own and practice them on your own. And definitely let me know if you have any questions about that. And I'll be happy to go with you on an individual basis in class, or we can do it on phone. We could do it on the phone or on a Zoom conference or Google Meet, however you want to do it. All right. Definition of a horizontal asymptote. The line y equals L is a horizontal asymptote if the limit of f of x as x approaches negative infinity equals L, or the limit of f of x equals L as x approaches positive infinity. So let's go ahead and highlight those components right there. So basically, if the limit is equal to a particular number as x approaches infinity, then that means you're going to have a horizontal asymptote. Now, some other important terminology. R is a positive rational number, and C is any real number. It's saying that the limit as x approaches infinity of any component over x to the r is going to have a limit of 0. So the limit as x approaches infinity will be 0. And the same thing goes for negative infinity. It'll also be 0. We're going to do some examples of that, what that means here in just a moment. All right, so okay, evaluating a limit at infinity. So determine the limit of, as x approaches infinity, of 5 minus 2 over x to the second. Okay, let's break it up into two parts. So the limit of 5 is equal to 5. Well, the limit of negative 2 over x to the second. That's the type of term we're talking about. As x approaches infinity, if you take x to the infinity power, you're going to end up with 1 over infinity, well, which in this case, or 2 over infinity as in this case, which is still going to give you a value of 0. So 5 minus 0. Because this right here, and I'm going to highlight this right here has a limit of 0, because that's what this right there was talking about. Anything x to any power, when it's underneath, like you see here, has a limit of 0 as x approaches infinity or x approaches negative infinity. And then, of course, 5 minus 0 is just simply 5. Okay, Now, example number 2. This seems kind of tricky because what's going to happen is this. If I were to plug in infinity for both components, I'm going to simply get infinity over infinity. I don't want that. So I want to break it down. Here's what we're going to do. We're going to divide out the highest power of x, which in this case is x to the first. So I'm going to take a moment and I'm going to divide 2x by x minus 1 over x. That's just on the top. And on the bottom, I'm going to do the same thing. So I take the highest power of x, which in this case is x to the first. And let me clarify something. It's always what you see, the highest power of what you see on the denominator side. So in other words, what's down there. It just happens that they're both equal to each other. So here, 2x over x is just simply 2 minus 1 over x, and then 1 plus 1 over x. All right. Now we can simplify. So if we take the limit as x approaches infinity of 2 minus 1 over x, or 1 plus 1 over x. Now what's going to happen is the limit of 2 is just simply 2 minus 1 over infinity. We learned earlier that that's going to have a limit of 0. Same thing down here, 1 plus 0, so 2 over 1, which is just simply 2. All right. So the thing you got to remember is you want to divide by the highest exponent in the denominator, which in this case is x to the first. And since they have to both be the same, it works out good. All right. Let's try a few more examples. Okay, so for this next one, we're going to do the exact same thing before. Remember, we always divide by the exponent of the denominator, which in this case is 3x to the second. So let's do that. Divide 2x over x squared plus 5 over x squared. And then 3x squared over x squared plus 1 over x squared. And then we'll simplify that. We get 2 over x plus 5 over x squared equals, over 3 plus 1 over x squared. Well, if you look at this, each one of them has a limit of 0 with the exception of the 3. So I got 0 plus 0 over 3 plus 0, which is just simply 0. Simply 0. Now, this next one looks identical to the first one, except for instead of 2x, it's 2x to the second. So let's simplify that one. So I got 2x squared over x squared because that's the value right there, plus 5 over x squared all over 3x squared over x squared plus 1 over x squared. Remember, we're dividing by the value of the exponent of the bottom term right here. So that's going to give us 2 plus 5 over x squared all over 3 plus 1 over x squared. Well, when we do that, that's going to give us 2 plus 0 over 3 plus 0, which is just simply, and I'll just write it here, 2/3. And then the last one is very similar to that. But remember, we're dividing by the one on the bottom, which in this case is 3x to the second. So I got 2x to the third over x squared plus 5 over x squared all over 3x squared plus 1 over, and both of them are over x squared. Well, when I simplify that, I get 2x plus 5 over x squared. And then I get 3 plus 1 over x squared, which gives me, basically, it gives me 2 times infinity plus 0 over 3 plus 0. So basically, my limit is infinity. And I think I'm going to stop here for the moment, and we'll pause and we'll come back and we'll do